We're all using software constantly, right? On our phones, our computers, it's everywhere. But have you ever really stopped to think about what makes one app totally solid and another a complete mess? Well, today we're going to pull back the curtain and see exactly how you build software that, actually works when you need it to.
Oh, you know that feeling for sure. You've got one app that just runs perfectly, year after year. And then you've got another that crashes if you even look at it the wrong way. So, what's the deal? Is it just random luck? Magic? No, not at all. It's actually a really deliberate, structured process, and we're about to break down exactly how it's done.
Okay, so where do we even begin? Well, long before anyone runs a single test, the foundation for quality software is already being laid. It all starts with the blueprint, basically the rules of the road that everyone on the team agrees to follow. The easiest way to think about this is like building codes for a house, right? You can't just throw up a building however you feel like it. You have to follow specific rules to make sure it's safe, stable, and so that some other builder can come along later and understand what you did. It's the exact same idea for software. These standards make the code readable, predictable, and way easier to fix when something goes wrong. And this really gets at the heart of it, writing clean code instead of complicated code. Simple rules like keeping a chunk of code, a module, really short are incredibly powerful. I mean, a 20-line function, a developer can look at that and understand the whole thing in seconds. But a 200-line monster function, oh man, that's just a playground for bugs to hide in. Same goes for avoiding clever code. If your teammate can't understand it at a glance, it's just a time bomb waiting to go off later. All right, so you've got your beautiful, clean code that follows all the rules. Awesome. But how do you actually find the bugs? This is where testing comes in. And it turns out there are two major philosophies for how to even approach it. At its heart, software testing is basically a hunt. It's this systematic mission to try and break the software, to find all the errors and the weird flaws before it gets into your hands, the end user. The goal isn't just to prove that it works, it's to find out all the ways it can fail. In this image, it just perfectly shows the two big schools of thought here. On one side, you've got black box testing. You treat the software like, well, a mysterious black box. And on the other, you've got white box testing, where you can see all the internal wiring, all the plumbing, everything. So the key difference here is all about perspective. With black box testing, you're basically acting like a real user. You have no idea what's happening under the hood. You just care if it works. You put something in, you check what comes out. Simple. But white box testing, that's the developer's view. They're looking right at the code at every single logical path, making sure the internal machinery is running exactly the way it's supposed to. Okay, but here's the thing. Testing isn't just one single action. It's not like you just test the software and you're done. No, it's a process that happens in layers, building on itself. You start with the absolute smallest piece and you work your way all the way up to the entire system. And these black and white box philosophies, they aren't just applied randomly. They fit into this really structured, layered process. We're talking 4 main levels here: unit, integration, system, and finally, user acceptance testing. A really great way to picture this is to think about building a car. First, you test the individual spark plug. Then you test the whole engine. Then you test the car as it's rolling down the assembly line. And finally, you let the customer take it for a test drive. So we start at the absolute bottom, the tiniest level imaginable. That's unit testing. This is usually the developer who wrote the code checking each individual component, a single function, one little piece of logic, all by itself, basically asking, is this one single brick solid before we add it to the wall? Okay, so our individual bricks are solid. Now what? Well, now we start putting them together to build the walls and the rooms. That's integration testing. Here, we're checking the connections. Does data flow from one part of the app to the next like it's supposed to? When you flip a light switch in the bedroom, does the right light actually turn on? And teams can tackle this in a couple of ways. You can go top-down, where you start with a big picture, like the main user screen, and then test your way down to the smaller pieces. Or you can go bottom-up, doing the exact opposite. You start with the fundamental bits and build your way up. Both work, it just depends on the project. All right, next step. The whole house is built. Everything's connected. It's time for the full inspection. This is system testing. Now we test the complete, fully integrated software as one giant thing. Does it do everything we said it would do, way back in the planning phase? This is where we check the whole end-to-end experience. And finally, we get to what might be the single most important step of all, user acceptance testing, or UAT for short. This is the moment of truth. You hand the keys over to the actual user, the customer, and you ask them, is this what you wanted? Does it actually solve your problem? Their thumbs up is what determines if the software is really, truly ready. So to make this whole black box idea a little less abstract, let's look at a classic technique. Imagine you've got a form online that only accepts ages between 18 and 60. Now, instead of testing every single possible age, which would be crazy, you use something called boundary value analysis. You focus right on the edges, because that's where bugs love to hide. So you test 17, which should fail, 18, which should pass, 60, which should pass, and 61, which should fail. It's just a smarter, way more efficient way to find the really critical problems.
But wait, the story doesn't just end once the software goes live. In a lot of ways, that's just the beginning. The job of keeping software healthy and reliable, well, that's a job that never, ever ends. Sooner or later, a bug is going to pop up. And when it does, the process of hunting it down and fixing it is called debugging. It's pure detective work, really. You have to trace the symptoms all the way back to the root cause in the code, and then, very carefully, apply a fix without breaking 5 other things. But debugging, that's really just one piece of a much, much bigger puzzle. And that puzzle is called software maintenance. This is pretty much everything that happens after the software is delivered. Yeah, it's about fixing bugs, but it's also about adapting to new operating systems, making things run faster, and even adding brand new features that users are asking for. And this table really clears things up. Most of us probably think of maintenance as just corrective, fixing bugs that people find. But a massive amount of the work is actually perfective, which is improving the software or adding new features people want. Then there's adaptive maintenance, like making sure the app still works when a new iPhone comes out. And my favorite, preventative maintenance. That's like renovating the plumbing in your house, not because it's leaking, but to make sure it never leaks in the future. It's proactive work to prevent future headaches. So what's the big takeaway from all of this? It's that the rock-solid app you use every single day, it's not magic. It's not an accident. It's the result of a really deliberate, disciplined process, all the way from setting clear rules for writing code to layering on all these different kinds of tests, to the constant polishing and maintenance that happens after it's launched. Think about it. The very software you're using to watch this right now, it went through this whole ordeal. It passed hundreds, maybe thousands of tests just like these. But no system is ever perfect. It kind of makes you wonder, what one tiny bug, what one little unexpected flaw managed to slip through all those layers of protection? Something to think about. Thanks for watching.